Hello. Good morning. Hello. Good morning. Is my voice clear? Okay. I think in the last class we have completed exercise 1.1. We completed all the question of exercise 1.1. I think I started some portion of irrational number na.
Yes, sir. Average something
Okay.
method.
Just look. In the last class we have discussed about irrational number. Irrational
Number.
number. Then tell me what do you mean by irrational number?
Uh,
Okay. Who discovered irrational number?
Pythagoras.
Pythagoras. Who was Pythagoras? Pythagoras was a mathematician in ancient Greece. In ancient Greece. Okay, write on the class starting date and time. Look, irrational number means in last class we have discussed that irrational number means any number that cannot be represented in form of p by q. Okay, if represented by p upon q, that means rational number. If cannot be written in form of p upon q, that is called irrational number. And the special thing I was mentioned that time, that is the decimal expansion is, tell me, irrational number decimal expansion is which type?
Two type.
No, particularly irrational numbers decimal expansion, non-terminating, non-recurring,
Recepting.
non-terminating, non-recurring,
Recurring.
non-recurring. That is the definition of a irrational number. Any number that cannot be written in the form of p upon q and whose decimal expansion is non-terminating,
Recurring.
non-recurrent. Okay. Then we have discussed some example, and that time I told you the number inside square root and the number should not be perfect square. The number should not be
Perfect square.
perfect square is the example of a irrational number. Root 2, root 3, root 5. You tell me, root 25 is rational or irrational?
Rational, sir.
Rational, because I can write this 25 as 5 into 5, and you know when you remove this square root, 1 5 will come outside. Okay.
Okay, sir.
Then the second example I was telling at that time, that is non-terminating, non-recurring. If any decimal having non-terminating, non-recurring or comes under irrational number, like 1.3254132. Okay,
Okay.
and that time I have discussed pi is rational or irrational.
Rational, sir.
Okay, remember the value of a pi is not 22 upon 7, it is approximately 22 upon 7. Okay, the value of pi is 3.141. Okay, it is a non-terminating, non-recurring decimal. Okay, and you know if any decimal whose decimal expansion is non-terminating and non-recurring, then it comes under irrational number na? For our calculation sake, we are expecting the value of phi is approximately 22.7. Okay,
Okay, sir.
that's why here you look the in example of a irrational number, pi is there. Pi is there na? Okay, that means we covered any number root over and the number should not be perfect square or the example of a irrational number, and decimal expansion should be irrational, sorry, non-repeating, non-terminating. Okay,
Okay, sir.
now you get a clear information about irrational number.
Yes, sir.
Okay, then move forward. Okay, just tell me some question answer. You know about Pythagoras theorem?
Yes, sir.
Tell me, what does this theorem state that?
Hypotenuse square plus height square equals
Hmm.
to base. Sorry, into base square.
Okay, Pythagoras theorem. Pythagoras theorem. Remember, this theorem is acted on or applicable on a right angle triangle. On a right angle triangle. This larger side in a right angle triangle, this larger side or in front of a right angle is called hypotenuse. Is called hypotenuse. This is called perpendicular. This is called base. Actually, there is a relationship between hypotenuse, perpendicular, and base, which was given by Pythagoras. Okay, the relationship is p h square means larger side square is equal to smaller side, the sum of a smaller side square. Okay,
Okay.
we are learning this concept because we required. Now we require. Okay, tell me. Suppose there is a right angle triangle ABC. Suppose there is a right angle triangle ABC in which perpendicular is 1 centimeter, base is 1 centimeter. Then hypotenuse is how much?
2 centimeter.
Okay, look. A square equal to p square plus b square. P is how much?
1.
B is how much?
1.
A square equal to 2. H equal to square root of 2, na?
Yes.
Then it is root 2 centimeter. Okay.
Okay.
Then same example. Perpendicular is 1 centimeter. Perpendicular is
1 centimeter.
base is 2 centimeter. Then hypotenuse is how much?
5. 5. Square root of 5.
Square root of 5. Okay. Then same thing. Perpendicular is 1 centimeter. Base is 5 centimeter.
5.
Sorry, 3. 3.
10 square root of 10.
Square root of 10. Why we are learning this? Now you can understand. Okay. The next concept is how to represent irrational number on number line. Our next concept is this. Okay.
Okay, sir.
Our next concept is, let us see how we can locate sum of a irrational number on the number line. Look. First I am telling, try to listen. Draw one number line. Okay, suppose the rational number is root 2. Suppose the irrational number is root 2. This is 0. This is 1. This is 2. This is 3. Look. Remember, few seconds ago I was discussing with you that in a right angle triangle, if a base equal to 1 centimeter, height equal to 1 centimeter, then hypotenuse is how much? Root 2. Okay, we are using this concept. Suppose I am taking a point A on number line on which the number is 1. Okay, then I am drawing one perpendicular. Remember, this perpendicular length is always fixed, that is 1 centimeter. That is 1 centimeter. Suppose this name is P. Then connect this OP. Okay. Then by taking center as O and radius as OP, got one arc. Okay. And the arc touches the number line on point C. And this C point is representing root 2. Okay.
Can you explain?
Okay. Look. First draw one number line. Okay. For root 2, 1, 2, 3. This is the number on number line.
Yes, sir.
Okay. Mark a point A on which 1 is present on the number line. Why you are taking 1? Because you know na, if base is 1 centimeter or perpendicular is 1 centimeter, at that time you will get root 2 as the hypotenuse. Okay, so I am taking a point A on the number line on which 1 is there. Okay, then draw a perpendicular to A. Draw perpendicular AP to A, whose length is 1 unit. Whose length is 1 centimeter. Always remember, for representing root 2, root 3, root 5, root 7, root 6, always this is a fix 1 centimeter. Only the base will change, but the perpendicular remains same. Then connect OP. Okay, connect OP. Okay, this is 1 centimeter, this is 1 centimeter, and this is a right angle triangle. Then hypotenuse is how much? Will be how much?
Hypotenuse will be 2 square.
Root 2, na?
2.
You remember? You understand?
Yes, sir.
Then put the taking O as the center and OP is the radius, make one arc. Draw one arc and name the arc as C. Okay,
Okay.
and the point on which the arc is touching the number line, that represent root 2. It is not. It is the root 2 centimeter. Okay.
Okay.
By taking this is the radius, we are cutting one arc that represent root 2. Okay.
Okay, sir.
This is the concept. How we represent root 2 on number line. For root 3, tell me.
3, 1.
First tell me. There is a right angle triangle. There is a right angle
Triangle.
whose perpendicular always fixed. How much? 1 centimeter. You have to find root 3. You have to find
Root 3.
root 3. It is 2. If I give 2, it will be become root 5. Think.
1.
Are you understanding my question?
Yes, sir.
My perpendicular is 1 centimeter. My base should be root 3. So, sorry, hypotenuse should be root 3. Then what will be my base? So apply this formula. A square equal to b square plus b square. Here you are finding b square, na? So b square equal to h square minus b square. You understand or not?
Yes, sir.
Then h is how much? Root 3. P is how much? 1. Root 3 square?
Root 3 square. Erase 1.5.
Root 3 square.
Root 3 square.
Are root 2.
9 square.
Okay, tell me. Root 2 into root 2 how much?
Root 4.
2, na?
2. Okay, sir.
3 minus 1. B square equal to 2. B equal to root 2. B equal to root 2. So that means here the base should be root 2. Okay?
Okay, sir.
That means how we represent root 3 on number line? Look once. For representing root 3, first you have to find the root 2. First you have to, because you have to take base as root 2, na? Here 0, here 1, here 2.
2.
First thing. For representing root 3 on number line, you require root 2. So first you represent root 2 on number line. How you represent? Take A as 1, then make one perpendicular. Okay. Connect the OP, and this is root 2 centimeter. By taking arc, this is root 2. This is root 2. Then what you should do? Now you take root 2. This is the base, na? Draw another perpendicular. Draw another perpendicular. Now give it as Q. Now give it as Q. Then connect Q and O. Okay? Think. It is a right angle triangle, na?
Yes, sir.
Whose base is root 2 centimeter?
Base.
Root 2 centimeter. Then perpendicular is how much? 1 centimeter. If you find the square, will be how much? Root 3, na? root 3 centimeter. So by taking this time you have to take OQ as the radius. Mark one arc, cut one, draw one arc. The point at which it intersect the number line, this is root 3. Okay.
Okay, sir.
Have you any doubt?
No, sir.
Okay. Then root 4. You know root 4 equal to 2. No need to draw. Then come to root 5. Come to root 5. First tell me. In a right angle triangle, if always remember perpendicular always 1 centimeter. Perpendicular always
1 centimeter.
1 centimeter. And this time your hypotenuse should be how much?
5.
Root 5.
Root 5.
Ah. Then tell me base should be how much?
Root 2.
2. That means this time you have to take your base as a 2. Your base as a 2. This time not 1. This time 2. Because you look na. Then perpendicular is 1 centimeter. Always it is 1 centimeter na.
Yes, sir.
Then connect O to P. Then connect O to P. Then by taking O as center and OP as radius, mark one cut. Mark one arc. And the point at which it touches the number line, this is the root 5. Okay.
Okay, sir.
Do you understand how to represent?
Yes, sir.
Okay. And what you should write? Write down. Question. You have to write now. What you are doing, the construction, everything you have to write now. The first question is locate root 2 on number line. Locate root 2 on the number line. You understand or feeling in difficulty? Tell me.
Sir?
You are understanding now?
Yes, sir.
Okay. Locate root 2 on number line. First you make the number line. Root 2 means base should be how much?
Root 2. Place will be 1, sir.
1. Below you write make a point. Make a point. Make a point A which represent which you understanding my writing?
Yes, sir.
You which representing 2 on the 1 on the number line, on the number. This writing is so much important. You understand? By doing this you understand, but you have to write na. Make a point A which represent 1 on the number line. Okay.
Okay, sir.
Make this as A. Then write from A draw a P. Draw a P. Are you listening?
Yes, sir.
Draw a P of unit length. Draw a P of unit length which is perpendicular to OA. Which is perpendicular to OA. Which is perpendicular to OA. If this is O, this is A. Perpendicular means it should be straight line. It should be straight line. Name this as P. Okay. First line you wrote make a point A which represent 2 on the number line. Second point you are writing from A draw a P of a unit length which is perpendicular to OA. Okay. Then write join OP. Join. Next line write join OP. Join OP. Then write taking O as center, taking O as center and OP as radius. OP as are you writing?
Yes.
Radius caught an arc. Caught an arc intersecting number line intersecting number line at point C. At point
C.
C. Join OR taking O as center and OP as radius caught an arc intersecting number line at point C. Okay.
Hmm.
That means it is telling you taking O as the center and OP as the radius.
Hmm.
Mark one chord, mark one arc, and point this as C. C represent C at last, right? C represent root 2 on the number line. Root 2 on the number line. In exam, you have to do everything by using your scale and a compass. Okay?
Okay.
It is the rough diagram. You can able to do that.
Yes, sir.
Okay. Complete.
Hmm.
Remember only one thing. Every time you have to do this thing. Nothing changes. But the concept is always before doing the question, look what is given. Which number you are locating on number line. Look this time root 3. This time
Hmm.
root 3. Think perpendicular always same. Perpendicular always same 1 centimeter. Okay.
Okay, sir.
Only you have to change the base. So think perpendicular is 1 centimeter and base sorry hypotenuse should be 3 centimeter root 3 centimeter na. Then only you can able to represent. Then base should be how much?
2. Root 2.
Root 2. If your base is a irrational number, then you have the irrational number which is coming as the base, you have to first locate this number. Okay?
Okay, sir.
If it is a whole number, then don't worry. That taking that whole number as the base, represent the number on represent the irrational number on number line. But if 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 your base is a irrational number, then first you have to locate that irrational number on the number line, then locate your given number. Okay?
Okay.
Means we represent root 2 on the number line na few seconds ago. Then look. After this, what should we do? For locating root 3. This time I am locating root 3. Same 0, 1, 2, 3. You have already written na how to represent. This is A na. This is O. This is P. And this is 1 centimeter. This is 1 centimeter. This is root 2 centimeter. This is root 2 centimeter.
Centimeter.
And now again what you have to write? Draw a perpendicular PQ. Draw a perpendicular. Sorry, from point P. From point P. Draw a perpendicular PQ. Okay.
Yes, sir.
After representing root 2, what you should write? From P. From P. Continue the writing. From P. Draw PQ. Draw PQ of unit length. Of a
Unit length.
unit length which is perpendicular to OP. Which is perpendicular to OP. Perpendicular to, you understand or not?
Yes, sir.
Okay. Then join QO. This time you have to join QO. Hmm. Yeah.
PS center, huh?
What?
PS center or OS center?
First you join na. First you join QO. Okay.
Okay, sir.
Then write down join OP. Join QO.
OP.
QO. Look, this is root 2 centimeter. This is 1 centimeter. And your hypotenuse should be how much?
3, sir. 3, sorry.
Root 3.
3 square.
Root 3. Root 3. Root 3. Root 3.
Root 3.
Then taking O as not P as, taking O as center, taking O as
center,
center, and OP as radius, and
OPS radius,
OP as radius, caught a arc, intersecting number line. Are you writing?
yes sir,
Intersecting
number line,
number line at point D, at point D, D.
DO,
And you know the value of root 3 is 1.732. You know na? So taking this, if you have to cut a point, it's point D. This is your root 3. Okay?
okay sir,
D represent root 3. Now you understand how to find?
yes sir,
If your base is a whole number, no worry, don't worry. Take base as that much, represent the number. But if the base is a irrational number, first you have to represent that irrational number on number line, then should go for the given number. Okay?
okay sir,
Then look. Suppose for root 5, because root 4 is not a irrational number, it is a rational number. Then root 5, then root 5.
right,
Think you have a one right angle triangle. You have one right angle
triangle,
triangle in which perpendicular always how much? 1 centimeter. Base is root 5. Base is
root 5, then
sorry
2,
hypotenuse root 5. Base is, will be how much?
2,
2. So this time don't worry because it is a whole number na. This time you have to take this much as your A point A. Okay.
okay sir,
Then whatever you wrote on your copy that should be right. And this time you have to take OP as the arc and cut one. The same radius and cut one arc. Okay.
okay sir,
Now you can able to represent any number on the number line, any irrational number.
sir,
General the question comes from root 2, root 3, root 5, root 6, root 7, root 9, sorry, root 11. Till this the question will be asked. Okay. If you understand how to represent root 2, root 3, root 5, then you can do any question coming from this concept.
okay sir,
Look, some question is given in here. In question in exercise 1.2, you have to represent root 5. You have to represent root 5. Okay. Read the first question of exercise 1.2.
first question, state whether the following statements are true or false, justify the answer,
Okay, you have to tell me the
true or
given statement is true or false, and you have to justify. You have to give the reason why your sentence is true or why your sentence is false. Read the first question.
every rational number is a real number,
Okay, remember this hierarchy. Number is divided into two category. Number is divided into
2
two
parts,
category. One is real number. One is
rational number,
real number. No. One is complex number or imaginary number.
number,
Complex or imaginary. Okay. Then this real number is divided into two category. Rational,
rational, irrational,
irrational. And this rational number is further divided into natural number,
number,
whole number,
integer,
integer. Okay, write on this hierarchy. And terminating decimal and terminating
terminating, non-terminating,
terminating decimal is comes under rational number. Okay.
okay,
And non-terminating recurring is also coming under rational number.
okay,
Non-terminating but recurring. Under irrational number, one thing is come that is non-terminating, non-recurring. Non-terminating,
non-recurring,
non-recurring. Write on this first.
yes sir,
As a complex or imaginary number you will learn in class 11. Okay. Hmm. Whenever you don't understand my writing, you will ask me. Okay. Complete.
Sir,
Complete this writing.
writing.
Okay. If you don't understand any writing, you can ask me.
Okay, sir.
Number are of two types: real number and imaginary or complex number. Real number is of two types: rational or irrational. Rational is further divided into any category: rational, natural number, whole number, integer, terminating decimal, non-terminating, non-repeating decimal, and irrational number is only one type: non-terminating, non-recurring. Okay,
Yes, sir.
complete.
Writing, sir.
Okay, after complete the writing, tell me. Complete.
Yes, sir.
Okay. Now you read this question.
Every irrational number is a real number. True.
Because real number is of two types: real number is the bigger container and rational irrational is the smaller container. So you can put smaller container in bigger container. Okay.
Okay, sir.
Read the second question.
Every point on the number line is of the form m square
Root
root
m, square root m.
square root m, where m is a natural number.
Do you understand this question?
Hmm.
Suppose this is a number line. Okay. Number line contain positive integer, negative integer also. Then tell me, the question is saying every point on the number line is of the form root 2m, where m is a, sorry, square root of m, where m is a natural number. Wait, tell me. Square root of minus 4. How much?
-4.
It is a number line, na? So it tells you that every number. If I put -4, that
-2.
no, it's not -2. Then tell me, forgot the minus concept. Root over of 1 is how much? 1.
Square root of 1 1.
Root over 2,
Irrational.
1.414 dot, dot, dot. Is 1.414 a natural number?
Hmm. Yes, sir.
A natural number means 1, 2, 3, na? 1.414 is a natural number.
Not irrational.
So is this sentence correct?
No, sir.
No. You understand? Or
Yes, sir. I can.
then third question. Every real number is an irrational number?
True.
Every real number is a bigger container.
Ah,
It is of two types: rational or irrational.
yes.
But the question is saying every real number is an irrational number.
No.
No, because 3 is a real number. Is it irrational? No. Okay. Understand or not?
Yes, sir.
Then come to question number 2. Read the question number 2.
Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number.
It is such a easy question. Have to tell me. It is such a easy question. Have to read the question 2 times.
Are the square root of all
Hmm.
positive integers irrational.
Remember. Always you think, sir, why it tells about positive integer if negative integer? It comes under imaginary number. Okay, it is another category which you learn in 11th class. So that's why it is writing in positive integer. Square under square root, if any negative number are there, that is called the imaginary number. Okay,
Okay.
so we don't consider negative number in this time. The question is saying, are the square root of all positive integer irrational? If not, what are you thinking? This statement is correct or wrong?
Uh,
Hmm.
Right.
Correct.
Sir, a square root of a all positive
Are
integer.
the square root of all positive integer?
Square root of 3 should also be.
Okay, look. Positive integer 1 is a positive integer.
Hmm,
Square root of 1 is how much?
1.
Square root of 2 is how much? Same root 2.
1
Same root 2.
point
Square root of 3. Same root 3. Square root of 4.
4 square root. Sorry, square root 2.
2. Square root of 5. Same root 5. Square root of 6. Same root 6. Square root of 9 is how much?
3.
3. The question is asking, are the square root of all positive integer irrational? Look here, 1 is irrational, 2 is irrational, 3 is irrational. So that means this sentence is incorrect, na? Wrong. If not, give an example. Look, these are the example. Okay.
Okay, sir.
Then you know how to represent root 5 on one number line. Don't require to explain. Okay.
Okay, sir.
Root 5, root 6, root 7. This is the homework. Write down. Represent or locate root 5, root 6, root 7 on number line. And you know how to represent?
Yes, sir.
First, in rough, you have to draw the right angle triangle. Perpendicular should be always should be 1. If it is root 6, then find base should be how much. If base is a whole number, then you have to draw the number line directly represent the number. If base is a irrational number, you have to represent that irrational number first on the number line, then the given number. Okay.
Okay, sir.
Read this question number 4.
Question number 4.
It is such a large question. I have to read.
Classroom activity.
Okay.
Constructing the square root
Hmm.
spiral.
Okay.
Take a large sheet of paper and construct the square root spiral
Okay.
in the following
Just wait. I'm ready. Classroom activity. It is a classroom activity. Constructing the square root of a spiral. This time you have to find. Okay. It is half, but you have to complete the spiral.
yes,
You have to
complete.
complete the spiral. It looks like this type. Okay. Take a large sheet of paper and construct the square root spiral in the following fashion. Start with a point O. Start with a point O and draw a line segment OP. Draw a line segment
Okay.
OP of a unit length. Unit length means it should be 1 centimeter. It should be
1
1 centimeter. Draw a line segment P1 to P2. P1 to
P2.
P2 perpendicular to OP1 means you have to draw this line perpendicular to OP. Okay.
Okay, sir.
Now draw a line segment P2 to P3. Look, P2 to P3.
3.
perpendicular to OP2 means you have to join this. Okay. Array, it's nothing here. Root 2, root 3, then root 4, root 5. You have to draw like this. Okay. Only you have to complete the spiral. It is not that much important. Only you have to remember. Okay.
Okay, sir.
Leave the question. Leave this question. You understand the above question?
Mm.
These three questions. You understand?
Yes, sir.
Have you any doubt?
No, sir.
Then come to real number and their decimal expansion. Real number,
That decimal expansion.
real numbers and their decimal
Expansion.
expansion. You know about decimal expansion?
Mm.
Terminating, non terminating. Okay, look. Let us take three examples: 10 upon 3, 7 upon 8, 1 upon 7. Okay. Pay special attention to the remainder. Okay. First, what are the meaning of 10 upon 3? Divide 10 by 3 na, and 10 become the dividend, 3 become the divisor. Divide and tell me the quotient.
Sir, 3.33 something.
You divide na? Okay, it is in your book na. Look,
I see.
10 divided by 3. 3 3 ja 9. If you subtract 10 minus 9, it's 1.
2.5.
Put one decimal in both the places in your dividend as well as in your quotient. Put 0, shift this 0, 10, 3 3 ja, again 9, again 10. Look,
3.3y.
3.333333. That means it is one type of decimal expansion because the main heading is decimal expansion. Okay,
Okay, sir.
look, when we divide 10 upon 3, we got the quotient as a 3.333. Okay, then in 7, in next case, when we divide 7 by 8, 7 by 8, now my quotient is 0.875 and it is terminating. It is terminating. And in the last case, when you divide 1 by 7, 1 by
7.
7, this time also look my quotient. In three cases, are you looking any different?
Yes, sir.
Uh,
First one is repeating, second one is not repeating.
that means
Sorry,
first one is
non-terminating.
non-terminating. First one is
Non-terminating.
NT means non-terminating. Second one is terminating. Third one is also non-terminating.
Non-recurring.
Right. In first one, look, it is non-terminating, but the digits are following a particular pattern. So that is called non-terminating, repeating, non-terminating,
Repeating.
repeating, or the another name is recurring.
Recurring.
In the second case and the last case, it is non-terminating, but it is not recurring or not repeating, not repeating or not recurring.
Recurring.
That means, look there, remainder in three cases. Look, if remainder is 0, if remainder is 0,
0.
so it is which type of decimal expansion?
Terminating.
Terminating. If it is other than 0, then non-terminating, then non-terminating. Okay, hello.
Okay, sir.
So from here we got one definition, that is, if the remainder becomes 0, that is which type of decimal expansion? Terminating. Which type of
Terminating.
terminating? Just wait 1 second. If remainder becomes 0, if remainder becomes 0, at that case, you 100% got terminating. If remainder is does not equal to 0, at that time non-terminating. Okay. Look, that is written on your book. In the example 10 upon 3 and 1 upon 7, we notice that the remainder repeat after a certain stage, forcing the decimal expansion to go forever. In other words, we have repeating block of digit in the quotient. We say that this expansion is non-terminating. You understand?
Okay, sir.
The usual way of showing that 3 repeats in the quotient of a 10 upon 3 is to write it as 3.3 bar. This symbol is called a bar.
Bye.
Bar means this number is repeating
No.
to finite time, infinite time. Okay.
Okay, sir.
Here also look 142857. 142857. It is also
Recurring.
recurring. But if you look the pi value, it is a non-recurring. Okay. How you write 1.2857? 1.2857. Okay. Bar. Where the bar above the digit indicates the block of a digit that repeats. This bar represents the block of a digit or the single digit that repeats. Okay.
Okay, sir.
Here you look 3.57272. If I put the bar on 72, that means only this
Five.
block of only 72 is repeating, not 5. Okay.
Okay, sir.
So all these examples given us non-terminating recurring decimal expansion. Okay.
Okay, sir.
Now suppose on the other hand, on you work on the number line, you come across a number like 3.142678 whose decimal expansion is terminating, or a number like 1.2727, that is 1.27 bar whose decimal expansion is non-terminating recurring. Can you conclude that it is a rational number? That means look, decimal expansion, terminating, non-terminating. Terminating you know directly comes under rational number, directly comes under
Rational number.
rational number. Non-terminating is of two types:
Recurring.
non-terminating recurring,
Non.
non-terminating non-recurring. So you remember this is also comes under decimal rational number. Okay.
Okay, sir.
And decimal number, sorry, rational number means we have to able to represent p upon q form, na? Just wait, how we represent, you understand? Okay.
Okay, sir.
We will not prove it all, but illustrate this fact with a few examples. The terminating cases. Terminating cases means, look, I'm telling you that na terminating a rational number, non-terminating recurring also rational number. Then what are the three characteristics to know whether the given number is rational or not?
Where we can write
Hmm.
the number into p by q form.
P by Q form.
Q is not equals to 0,
Q is not equal to 0.
and there p and q are integer.
PQ must be integer. PQ must be
Integer.
integer. This is the three characteristics. If I telling you that terminating or comes under rational number, that means terminating decimal I can write in P upon Q form, where Q does not equal to 0 and PQ must be integer. Suppose the example is 1.5. It is a terminating decimal.
Hmm. 15 by 0.
15
15
by
by
10. Look how many digits are. Remove the decimal point, write down the number as exact on the numerator, and count how many digits are there, how many decimal places are there. Depending upon this, on denominator you have to put that many zero with along with 1. Okay.
Okay, sir.
Like this, 2.723, 2.723. Convert this into, hmm.
2.723 by
Remove the decimal point, and the number you obtain write down on numerator. Then count decimal places. How many decimal places are there? Decimal places means after decimal digit, how many digits are there? How after 3, then put 30 along with 1. Okay.
okay, sir.
This is how we convert terminating decimal as a rational number. But sir, what about non-terminating? What about non-terminating
Non terminate.
and recurring? Look, suppose the example is 0.3 bar. 0.3
bar.
bar. Look, this is a new point for you. 0.3 bar. What is the meaning of 0.3 bar? I can write 0.3333 na.
Mm.
Suppose this 0.33 I can write as x. X equal to 0.3333. Okay? You understand?
Yes, sir.
Then look, after decimal, only one digit is repeating na.
Mm.
So if you one digit, then multiply by 10. Multiply both the side by 10. Multiply
Both are side by 10.
both the side by 10. By
10.
10. Then it will become 10 into x. 10 into
10
x.
into x.
And it will become 0.3333 into 10.
Mm.
10 into x how much?
10x.
And 0.3333 into 10.
10.333.
Hmm.
Right.
Remember, if any decimal number multiply by 10, the decimal point comes one step to the right.
3.333. 33.
3.33333. 3.3333.
10 by 10 by 3.
Then 10x equal to how much?
3 by, sorry, 3.333 by 10, huh?
And after multiplying, we got 3.33.
3, 3. Okay, 3.3.
Hmm. Then this 3
By
and
10.
hmm, 10. Oh, just wait. 10 into x. 10 into this. It will become 10x. 3 0.33 multiply. Look. 0.3333. When you multiply by 10. When you multiply by
10.
10, it will become how much?
3.3333.
3.33333. Okay. Then we come to this point. 3.333 equal to 3 plus x. Since x equal to 0.3333, that means I can write 10x equal to 3, and I know dot 333 is how much? X.
X, X.
Then 10x equal to 3 plus x. If I came this x into this side, 10x minus x equal to 3. 10x minus x how much?
10x minus x. 0.
10x minus x,
9, sir.
9x equal to 3. Then x equal to how much?
X equals to 3 by 9.
1 by 9. 1 by 3. 1, 3 by 9. If I simplify it become 1 by 9. 1 by 3. Okay.
Okay, sir.
Now you understand how to do this?
Yes, sir.
Or having any doubt?
Hmm?
Have you any doubt?
No, sir.
Okay. Like this you can able to do 1.27.
Hmm.
This time you have to multiply with 100. This time you have to multiply with 100.
Yeah.
Hmm.
Okay. 100.
Why are you multiplying with 100?
Because point is after 2 digits.
If you look 1.27 after point there will be 2 digit. So it will become 100x equal to 127.2727. Okay,
Yes, sir.
you can able to find now.
Hmm.
Same thing you have to repeat with all these number. Okay,
Yes,
then
sir.
exercise 1.3 is your homework. You can able to do na exercise 1.3.
I'll try, sir.
Look all these questions. Try exercise 1.3. Okay, write down the homework.
Okay, sir.
Exercise 1.2.
Yes, sir.
And exercise 1.3. Okay,
Okay, sir.
that's enough for today class. Remember from the class, the next class is on Monday. Okay, sorry, Tuesday. Okay.
Okay, sir.
Okay.